A year ago, I was in London at a conference called SQL Bits at the Excel Center. Maybe some of you were there. And we had announced already the private preview of SQL Server 2022. So I was kind of showing it off, right? I was showing some of the new stuff. Didn't feel polished. Slides maybe not felt polished. Hey, it's generally available now. So what you're going to see for the next 15 minutes is a more polished version of what we released. Hi, I'm Bob Ward from Microsoft. First of all, thank you so much for supporting SQL Bits and coming to Wales. And thank you so much for coming today. How do you talk about SQL Server 2022 in 50 minutes? I talk pretty fast, so I can try that. I had a workshop here the other day. It was a full-day workshop. I have a resource for you to look at that later. I don't know if you attended that or not. But here's what I'm going to do. I'm going to give you some of the major capabilities we've put into the product in SQL 2022. I'll dive in a little deep in a couple areas I think I'd like to show you. I gave you clues in the keynote when I was right here through whatever that was, about a few demos that we showed you so quickly, and I'll actually do a little more deeper on those today. And then for fun, tomorrow in the same room around 10 o'clock, I have a hidden gem session. I have some stuff that didn't quite make the press and the headlines that I will show you tomorrow as well. Let's do some logistics. Number one, everybody wants the deck. I get it. The deck you're seeing today is here on SQL Server 2022 decks. It's there right now. And the two demos I'm showing are in the deck. They're recorded demos. And here's what's really fun, maybe not so fun. You can unmute the slide in PowerPoint and listen to me drone on to these demos. You can go back and look at it later. Of course, you can get the recording from Bits and hear me talk about it. Also, our SQL Server 2022 workshop link is there. It's a GitHub repo that we used to do hands-on the other day, on Wednesday. What day is it? I don't even know what day it is now. I think it's Friday, right? Full day linked. You can go back and see what everybody experienced in the workshop yourself and see a massive deck of all the functionality in SQL 2022. And I have a resources slide at the very end of this session just to put up there and let you look at it. You're going to have some questions. It's a large auditorium. So the only way really to do that practically is to use the app or the website. I can't even pronounce it. Anybody know how do you pronounce that thing? Canopy. Thank you very much. And there's a monitor here where I can see this. I'll have fixed sets in scenarios where I'll stop and say, hey, let's see if there's a few questions to answer. If you're here in person, here's the good news. If you're like, look, I didn't really get to answer that question, immediately after this really nice lady named Marisa is going to walk up here and say, Bob, you need to go do a book signing. So I'll be doing a book signing at 1 o'clock today for an entire hour there at the booth. If you want to come by and chat with me, ask a question you heard about today, and also get a signed book, happy to do that as well. And then I'm here the rest of the day at this conference and tomorrow, so if you just happen to run into me, please ask your questions. By the way, real quick, if you didn't know this, the city skyline behind on that picture is Dallas, where I'm from, and that was the project name. I was fortunate here, now my 30th year at Microsoft, to finally get the opportunity to name a project at Microsoft, and I named it after my home city in Texas. Why do we call it the wheel of power? Like, what are you talking about? Well, consider SQL 2022 being the hub and these being the spokes, which are the major categories and capabilities of SQL 2022. And in the workshop, each module represents one of these categories with tons of examples and exercises for you to try on yourself. But what we'd like to do is take a couple of these areas and explain more of what we've done there and give you some examples to give you a feeling of what's possible. Because probably while you're here is you're like, I'm not ready to install this yet. I'm thinking maybe I might want to upgrade to it, but I don't really know what's in it. Is there true value of why I might want to go to SQL Server 2022? But know this, the fact that we release SQL 2022 is a commitment from Microsoft that SQL Server is not going away anytime soon. We continue to innovate on the on-premises product, and it helps drive innovation for us in the cloud as well. So some of the things interesting in this release were not a cloud-first approach. They were a SQL 2022 approach first, because we could iterate a little bit in a different way there, and then we're putting them in the cloud, which is kind of strange for us, but I kind of liked how we did that in some areas. So let's first talk about cloud connected, because I want to make sure I explain to you some myths that have been talked about this area. Consider SQL Server right now underneath this dashed line is your environment. By the way, it could be an Azure virtual machine, but consider it just maybe your on-premises environment. So first of all, we're going to talk a little bit more in detail, because I've had a lot of questions in this area. How does this managed instance disaster recovery thing work? We'll show you a little bit about that. One thing I will not get into details, but you need to know about this is Synapse Link. I can take SQL Server, I can tell Synapse what database and what tables to synchronize, and then it will use a similar technology as change data capture, not the same thing, but do automatic changes into Azure Synapse, into SQL dedicated pools. This is kind of nice to offload analytics and put your analytic workloads in Synapse now instead of having run those on SQL Server. And then there's a series of cloud services that are authentication and security related. And to get those cloud services, you must install something called the Azure extension for SQL Server, which I'm going to show you in a demonstration you can do during setup or post-setup. And it's going to install some software, which you'll see in the demonstration, called an Azure Arc agent. In addition, in the demonstration you'll see, you can get some other services. I call these Azure Arc services. And the family of those is what we call an Azure Arc-enabled SQL Server. Yes, we need a shorter name. But what it means is I'm taking an existing SQL Server, connecting it to Azure, and getting value. And as it turns out, you can do that with SQL Server and not incur any Azure subscription costs just to get connected. And there's actually some value we'll see in the demos. You may have seen me fly by that during the keynote of things like inventory. On your left, Managed Disaster Recovery and Synapse Link do not need that Azure Arc Agent software. We use distributed availability groups built into the engine to give you managed disaster recovery, and we use the self-hosted runtime on your network somewhere to synchronize changes from a control perspective with Synapse. The runtime does not actually move data, it just is a control mechanism to tell SQL Server to move data. So this is a great overview of the cloud-connected story in SQL 2022. It's the most ambitious thing we've tried yet to date to do that. Let's talk about this managed instance for a second architecturally, because I got a lot of questions about this. Huge assumption. You set up an Azure network. You're like, whoa, that's a lot. Well, we need a whole other session to how to do that, right? But let's assume for a second you've got that configured so you can connect a SQL Server to a managed instance you've deployed. And by the way, keep in mind here when you look at these steps here, that in SSMS, you can do this to a wizard. But I'm showing you the step-by-step approach of how it might work. So first of all, if you do not have one, will build an availability group, or we'll use one that you have. Did you know that you don't need a cluster to use an availability group, and you don't even need a replica? You're like, what the heck would I do that for? Well, first of all, if you don't use a cluster, we call this clusterless. It's just used to ship changes between two SQL servers. We built this back in 2017, primarily for Linux, but it works also for SQL and Windows. And you don't need a replica, because if you want to be part of a distributed availability group, you can do that. And as it turns out, you can be part of a distributed availability group that's in managed instance. Because guess what? Even if you do a general purpose managed instance, there is an availability group waiting for you to use behind the scenes. Or if you use business critical tier, there's a true availability group that has replicas behind the scenes. So we can attach these together and link them, that's why it's called link, and synchronize and see your database from this primary SQL Server that you own to a managed instance. You're like, well, that's really cool. What happens next? Well, guess what? You just start making changes just like a DAG, a distributed availability group, in an async mode, and we will start shipping those changes over to managed instance. And you can have that model set up very seamlessly and easy through a wizard with SSMS or a series of scripts. So what we're really doing, quite frankly, is taking the concept of a distributed availability group and using managed instance to be that partner for us. And once you do this, you can actually go do an online failover between SQL Server and managed instance. Now, what you saw Dr. Danny show you in the keynote is a preview of an online version of this back and forth. Okay, that's in private preview today. You sign up with us. You can literally just switch back and forth between these models all day long. What we have now in general availability is this concept you see in front of you in an offline mode. And you're like, what the heck do you mean by offline mode? Well, you set this up as a linked system, and if you need to fail back, you can do a restore backwards. And you're like, well, that doesn't seem very practical, but you can do it. You can do it, and we'll show you why in a second, why it's compatible to move from managed instance now back to SQL 2022. But here's something important to explain. As it turns out, before SQL 2022, specifically 16 and 19, you can set up what I show you in this diagram for migration purposes. So you can take your SQL 16 system, you can set it up, you can synchronize it managed instance, you can get changes shipped over there, and if you want to, you can map all of a sudden just to make it an online migration. You can even read from the managed instance secondary before you do the migration. For SQL 2022, you can use it for disaster recovery in this offline mode. Online failover, but offline failback. And it's our intention for us to allow you to declare that managed instance as disaster recovery site and not pay for a SQL Server license. That would be pretty cool. So how about this backwards thing? How is that even possible? How can you restore back when there's no way to do that today between a higher version of SQL Server and a lower version? Well, as it turns out, the reason you can never do that in the first place is that there's a database versioning inside the structures of our databases. It's the format of system tables and various structures that we have. And as you upgrade from one SQL Server to the next, we upgrade these structures, which is why you can't go backwards. You may not have known that every managed instance in the world today is at this database version number aligned with SQL Server 2022. It does not prevent the managed instance team from iterating a managed instance, because as long as they create features that don't change that number structurally, it's compatible to go backwards. So what can happen is, once you fail over to MI, you could actually stop the write workload on MI. You could then do a copy-only backup, which you're allowed to do today on MI, to Azure Storage. You then can restore that to SQL Server 2022, and we will allow you to do that. You can even do this just without even setting up the online failover process in the first place. If you need offline copies of managed instances, not in Azure Storage, somewhere on premises, you can use this system today with SQL 2022. This is because the database version number is locked into SQL 2022 and not changed until the next major version. So we now have a process for you to have offline backups of managed instances, and it could be used for this offline failover scenario now with SQL 2022. But keep in mind that what the managed instance team wants to do is provide to you, and in preview today, a way to switch back and forth in an online fashion, just like a DAG between a primary, secondary role. That's what Dr. Danny showed today. But I wanted to show you what's possible even in general availability of what we ship in SQL 2022. And of course, you would migrate your instance objects, and if you wanted to, you could turn around and create the link again once you had actually made this fail back to SQL 2022. And that's part of the big cloud-connected story that we offer as a managed disaster recovery site. I call it managed because once you use managed instance as the DR site, we're backing it up. We're keeping it available for you. We're keeping it always ready to go whenever a disaster strikes, so you can know the DR site's ready to go when actually you need it. So another piece of the puzzle that we showed and flew by in the demo, and I just showed you what it was defined as Arc-enabled SQL Server. Well, what do you get out of that? First of all, you can now do SQL Server on premises through a pay-as-you-go licensing model, standard or enterprise. What does that mean? That means once you set this up, and you're not required to set it up, but if you want to, you can, you now would pay Microsoft with your Azure subscription on a per-hour, per-core basis for your SQL license, freeing you up to use your other SQL licenses for something else. We've seen customers want to do this for like temporary periods of time to stand up a SQL Server for 2 months and just use pay-as-you-go. You get free inventory, which I'm going to show you in a second. How is that even possible? You can get best practices assessments from Microsoft, which will show you exactly what that looks like configuration advice of your SQL servers. Defender for SQL, we showed that in the demo, right? How you can use Defender now to look for things like SQL injection attack. And for SQL 2022, if you set this up with this Arc agent, you can get Azure Active Directory for multi-factor authentication, a common ask request, and then Purview allows you to govern SQL Server logins and permission rights for Azure Active Directory accounts. But let's take a look at it a second for this Azure Arc-enabled SQL Server scenario. So again, one of the things I love about doing recorded demos is that they always work the same way. But also you can go back and get this deck later and just play through it yourself and pause it. So let's do that. Let's go through and look at this recording, and I'm showing you extra stuff that I flew through in the keynote and explaining it. So first of all, notice the setup screen in SQL 2022 now. This is just in SQL 2022, where I can choose pay-as-you-go billing now, and I can pick enterprise or standard. That's part of the setup process itself. You can do this after the fact too, by the way, if you don't do this during setup. So let's say you choose that. In order to make that work, you must install the Azure extension for SQL Server, which you will see us right here on the screen do. If you select this, you must first have an Azure subscription, which I did in this case. Again, be clear, you can do this post-setup if you want to. I put in my login. I put in some things like a resource group, a subscription ID, but let me make this clear. You are not installing software in Azure. You're just connecting your SQL Server to something called a resource in Azure. And I'll explain in a second why that's important. You can even put a proxy in here. So you pick a region, you pick a resource group to organize your resources, and then you continue in the setup process. We will then install agents on your system and connect you to Azure to get these services I talked about. So one of the things I love doing in my demonstrations is show you behind the scenes what we're doing, because people are like, I'm not clicking that until I know what you're installing in my virtual machine. So this is what it looks like. If you go look and install programs, sorry, let me go back here. Well, that didn't work like I wanted to. There we go. So I looked at installed programs on my SQL Server, and I found 3 pieces of software that are installed because I connected to Azure extension for SQL Server. First of all, I get the connected machine agent. That is a piece of software that is for Azure Arc in general. So if you just said Azure Arc for Windows, for example, that would be on your machine. Then the monitoring agent is for Defender. And then the SQL Server extension is our software from the SQL Server team to do things like pay-as-you-go billing, Purview, AAD, best practices, all of those type of things. So there are 3 services that you could potentially see in your SQL Server. On Linux, they're daemon programs, right, that run. So if you're wondering, like, what is Microsoft installing? As it turns out, there are Windows services. And that Azure extension for SQL Server, by the way, can be actually through our Service Control Manager, can be stopped and restarted if necessary. So that's what's installed on your machine. Again, by just doing this, I did not incur any money from Microsoft. I just connected myself to Azure. And you're like, okay, well, what do I get out of this? So look here. Here is a look at the portal of my SQL Server, and I start seeing properties through the resources. Again, I'm not installed in Azure. I'm installed in my environment. I see pay-as-you-go. I can see a list of databases all across this instance right here, and various properties of the database itself. We're just extracting SQL metadata for you and putting this into the cloud itself. So that's pretty interesting. That's all exciting. But what else can you do? Well, one of the things I showed and flew by in the keynote was the ability to do inventory. What you see right here in front of you is something called Azure Resource Graph Explorer. That is a piece of software in Azure that, because I've connected SQL to Azure, I can go run something called KQL, like a query language. And I can go look at resources in the cloud, like a connected resource like this, and gain information. So it's one thing just to dump out a table, but what if you want to do aggregations like you all might want to do? So what I chose to do is do an aggregation here of DB compat levels. I'd like to know across all my SQLs connected to Azure, what are the compat level breakdown? You might not be able to do that today. You could have 100 SQL servers running in your environment and go like, I don't know how many compat levels are out there and who's using what. So this is a distribution of compat levels in my environment. That's pretty nifty. In this particular case, you can see I've got a lot of older compat levels at 110 sitting up there. The other thing I did is, could I go find out who doesn't have a backup? Maybe you can't even do that today in your environment across all your SQL servers. I can do that. I'm doing this all with inventory information that for free is stored in Azure. So I could connect 100 SQL servers and just see this show up in the cloud and use these various KQL queries to go look at that information. So that is a little bit of a feel of what just inventory looks like. There's a lot of possibilities here. Again, we're just storing metadata. This is not log analytics, any of those things you're paying for. This is what's called the resource manager that is for free as part of SQL inventory. We would like, quite frankly, to make this even richer. Things about availability groups and your availability status. Things that we can statically connect and run SQL queries against your environment and put into the cloud would be powerful. And here's the other thing that's cool. What if you had SQL servers connected to Azure, but SQL servers in Azure, VMs, managed instances, and so forth? What if you could run stuff across all of that and see aggregation like this? That is our intention, to provide that kind of functionality. The other thing that I did not show was something called best practices assessment. Now, this will incur cost because we store information in something called a log analytics workspace. So we've provided an interface on top of that. So you run what's called an assessment, or you schedule it. We will take some of the best practices we've learned at Microsoft over the years on SQL servers as static configuration information and run an assessment of your system. So we've got some visualizations we can show you of things that look like, or we can show you very detailed rules. Like, are you running instant file initialization or lock pages? We can see certain errors that may show up in your system. We can even detect if there's fragmentation going on in your databases. This is not a performance analysis. This is a snapshot on a scheduled basis. Are you running it on demand? And it's looking at best practices for things that we've observed over the years that you might want to actually deploy. So to be clear, once you connect yourself to Azure and run this, you get this capability, you incur some small costs for log analytics, and we perform this. So I was going through this with a customer actually a few weeks ago, and they said, this is really lovely here. This is all interesting, right? But I don't have 2022 yet. You can do this all the way back to 2012. So it's not part of a setup process, but you can set up scripts to do any of your SQL instances from 2012 to 2022 and get this kind of information in the cloud. Now the AAD auth capability and purview is specific to 2022 itself. Let me stop for a second and go look here at my magical keyboard over here, my magical dashboard, to see what kind of questions I have. What is the minimum vCores you must have for pay-as-you-go instances? I don't believe there's a minimum. I can go double check, but I haven't seen a minimum out there. The documentation discovers all the things about pay-as-you-go licensing, but I have not seen us describe what that minimum is. You do pay on a per hour per core basis. How many DR secondaries from different AGs can you have on a single managed instance? My understanding right now, the only thing you can do is have one. You'll have one availability group as part of one DAG with one managed instance for your database to connect over. Let me see if there's any other questions that show up. So that's just kind of an introduction to what we're doing in the cloud. I personally believe that this is an area we will continue to invest. I was talking to my boss, Assad Khan, about this here at the conference. People have been asking him about SQL Server futures. We will continue to see if we can find ways to connect you to Azure on your terms to see whether it's going to give you extra added value. The DR capability is actually pretty cool technology. Synapse Link's pretty cool technology. But this Azure Arc stuff has legs. I mean, if we could actually do some pretty amazing things for you at a low cost to help you manage across a bunch of SQL servers, there could be some value for you in seeing what's possible in your system. Okay, so one of my favorite parts of SQL Server 2022 is intelligent query processing I call next generation. Why do I call it next generation? Because we've built on the power of what we've done in the past. So for example, if you install SQL 2022 and you're on any DB compat level, you get some functionality. You get a new set of approximate functions for percentile processing. That's actually way cool, based on sampling. You get something called optimized plan forcing. That's a really interesting one. If you run into what we call compile storms today, where your server restarts and everybody tries to compile a bunch of really heavy compilation expensive queries, we have ways of persisting some of the binary of compilation into the query store to make that faster. And we've actually seen benefits of that from some of our first-party customers like Dynamics or SharePoint have benefited from this technology. Again, that's independent of DB compat. In addition, if you're on DB compat 140, and of course we make this very easy for you to remember 140. Everybody remembers that SQL 17. And the way you know that, by the way, it's the version number. 14.x is 140. Sorry, we made it hard for you, but that's what it works. We started in that version to do something called memory grant feedback. For those scenarios where you're plagued by resource semaphore waits, or IO completion waits, or spills to TempDB, we created a dynamic way to take feedback from the query processor to adjust those grants so that you don't have performance problems. There's a couple issues with them. One is we had this crazy weird scenario where we would do this memory grant feedback and we'd keep adjusting back and forth, causing you issues. It was just too volatile. In fact, we finally just shut the thing down because we were seeing too much feedback happening each execution. Because when we execute the query, we know how to adjust it afterwards. The other problem is that we only put this in plain cache. So you shut down SQL Server, we start all over again. So in SQL 2022, we modified the algorithm to make a percentile approach. So after 3 or 4 executions, we lock in that feedback and we persist it into the query store. So if you restart SQL Server, it just works. It's a great example of us taking a common customer problem and trying to give you actually optimized health intelligence on the fly. But what's really amazing is with DB compat 160, in addition to this, you get parameter sniffing optimization, parameter sensitive plan optimization. I showed that last year at BITS. I showed it at PASS a lot. You get CE model feedback. That's an interesting concept where for those CE model problems, we can use query hints automatically solve your problems. And something I'm going to dive into a second called DOP feedback. You saw Aaron fly through an example of what that actually looked like. That is us trying to tackle the problem of fighting MAXDOP in your system. But it's not your fault that you forget. It's my fault for not reminding you that in SQL 17 and 19, we did all this stuff. Batch mode on row store, which just happens automatically for you, could be one of those groundbreaking things we put into the optimizer, especially for scan type scenarios. And it just works if you're on these compat levels of SQL Server. Last year at SQL Bits, I was with a former colleague of mine that's no longer at Microsoft, Pedro Lopes. He's like to me, like the grandfather of this technology, right? And one of the legacies he left is the two things. I remember him telling me this before he left Microsoft. He goes, I tried to make sure whatever I did in helping design these features or programming, managing these features, that we would do no harm. That when we build these facilities of automation in, it doesn't make you slower. Because guess what? If we do that, you don't trust us anymore. So I think we've done a good job of that. And if we've done that, you need to tell us that we've actually done that. And it's a bug, and we'll fix it. The second is you get to turn off what you want. So imagine going to 160 with all this fun stuff we've built, but say, I don't really want the PSP optimization, but I want everything else. You can selectively turn on and off what you want at the database level and at the query hint level. So you have a lot of automation that we're putting into intelligent query processing, but you can control the intelligence part per your workload needs. And the query store is your tool, which is now on by default in SQL 2022, to go measure and see what those differences are, because we actually store DB compat in the query store. You can also see in the slide right here, the little tiny icons indicate functionality that you need the query store for to enable. One of those is degree of parallelism feedback. Nobody thinks that MAXDOP is a problem, right? I mean, everybody thinks it's not an issue, right? MAXDOP, who cares about that? Nobody has a controversy on what setting MAXDOP is, right? If you ask any database administrator, they're going to say, I have no idea what to set that thing to, except what Microsoft and the world thinks I should do. In fact, you go search and go ask ChatGPT, I did, what should I set that to? It actually came up with all these crazy different answers. It didn't even know the answer. So it's not that intelligent, by the way, just FYI. It's okay. It's a pain to set it right. But here's my contention. I don't think it's bad to have parallelism. So I don't want you to be fighting setting it at 1. Maybe you have scenarios today in an OLTP world where you should go set that to 1, and I get it, you should do that. But I don't want you to have to do that. So what do we do about this? How do we figure out how to help you? So first of all, whatever I'm about to tell you now, don't deviate away from setting MAXDOP. Keep whatever best practices you think you have today. And I know it's crazy what we provided to you. You set it at the server level, the database level, the resource governor level, the query level, and there's a precedence there. So if you have it at the query hint level, we always make sure we use that and we go upwards accordingly. What we discovered was, and this may seem like kind of nonsensical to you, or sensical to you, is that the more degree of parallelism, the more threads we need to run your query, the more CPU resources we need. And the less degree of parallelism was the less threads and less CPU. It turns out when we designed this feature way back in SQL 7.0, we designed it so that we pretty much would chew up as much DOP as we think we could, because we wanted to run your query as fast as possible. So we didn't really build a system that was oriented towards min-DOP. We built it towards MAXDOP. Like, can we go to MAXDOP and just fire it up and run as fast as we can? But what you've discovered in your environment is that causes sometimes some performance problems. So here's what we're trying to achieve with a concept called DOP feedback. We want to find the lowest degree of parallelism to achieve the same performance for your query. We call that parallel efficiency. So what we'd like to do is turn on the query store, turn on this database option, you start running queries. We determine if they're eligible because you're running in parallel. We look at your MAXDOP value that's applicable on a query by query basis. So it could be MAXDOP at the server level is 0 for you. I don't know, it could be on 32 processors. That's what Aaron showed. We'll show it in a second in the demo. It could be though for a specific query, you have a query hint for 1. So if that query runs, we're not going to do this feedback scenario. But for other queries where the MAXDOP applies at say 32, we will take a look at that query. And if one that's fairly repetitive, like one that takes a while and repetitive, not one-offs, we will employ a feedback system in cooperation between the query processor and the query store to achieve that parallel efficiency. So let me show you what it looks like, and let's pause to see what I'm talking about. We flew by it in the keynote. By the way, one thing I just have to admit to you, there's a lot of pressure in keynotes to go as fast as you can. So sometimes you're in the keynote going, oh, wait a minute, what was that? Which is why I gave you clues in the keynote that I would be talking about these demonstrations. So let's look at DOP feedback at a little bit slower pace. Okay, So here I am running SQL Server 2022, and I've got a stored procedure. And you notice right here, we're just showing you in here that we're doing a clustered index scan. Now, by the way, in my demonstration, and by the way, this is really cool, this demonstration is in the workshop. You can go back after the fact from this demonstration and go try all the stuff yourself, even on your laptop. But in this case, you notice there's a missing index that shows up because I just picked a scenario that I knew would force parallelism for a clustered index scan. Notice here, the degree of parallelism is 32. That turns out in my system, MAXDOP is 0, and I got 32 CPUs in an Azure virtual machine. So we chose to run this query at a DOP of 32. So what happens is when this query kicks in, and I've got this feature enabled, the query processor sends information to the query store. So here's how I turn it on. I set degree of parallelism at 160, compat at 160. I set a database option on. This is requiring an opt-in approach, not just 160. And I run my query. I'm going to let this run for a second. I'm going to pause and tell you what's going on. You do not need X events to make this work. X events are your friend, though, to see the cycle of what we're doing. Let me run this for a second, pause it, zoom in, and show you what we're doing in the process perspective. So we're going through a series of steps of feedback and validation. Let me pause right here. Let me zoom. Whoa, here we go, zoom it. So right over here, you can see, first of all, that we have determined the query is eligible. And that means it's running in parallel. It's been running a few times, like it's fairly repetitive, and it takes a while. It's not like it takes like 1 second. Why would we try to go improve that? That's like fine. Something in this particular case, it takes like 14 seconds. So here's the process, what we do. We say, oh, this is eligible. So let's go try and tell the query processor to lower this DOP from 32, and you can see here in the first attempt, let's go try 20. Now what we do in the system is we take your current MAXDOP, we never go above it. We never go above it. We take your current MAXDOP that is applicable for your query, and we, in a staircase fashion, will lower a number. We don't go from like 32 to 31 and 30. We chose in this case to go from 32 to 20. So we literally, the query store background task takes information, feeds it into the query optimizer. When it runs next, it looks at the query store background task and says, well, should I try a new one? It tries 20, and then as you see over here on the side, let's zoom over here, it goes through a validation test. And that validation test is not like a one-off here. Let me zoom back here. It's not like a one-off. It's a period of execution of a cycle. So we try to make sure over a period of time, this is why when you turn this on, you don't like in 5 minutes see all of a sudden we just start adjusting things. We let this thing run over time in your system to make sure we're making very conservative decisions and not harming you. So we take that 20, we run it once. If we run it one time, and we say, oh, whoa, that's slower than it was before, then we just say give up, revert it at that point, leave it at 32. So what we do is we say, okay, did we get the same duration of your query but a lower CPU? And if you look up here, you can see something called the adjusted elapsed time and average CPU time. Now notice here that the adjusted elapsed time from the original one was a little bit lower, like 14 seconds. What is adjusted? We factor out weights. We don't want to have anomalies from a blocking problem that happens one time affect this feedback loop. So what we're doing is we're adjusting out weights and focusing more on CPU. In this case, there were a total, and by the way, if you're wondering, well, how can I have more CPU than duration? It's the total number of CPU across all the threads. So in this particular case, I did lower my CPU from 40 down to like 32. I'm like, that's pretty good. So I try it again. I go back and try it again, and I try it again for a few iterations, and then I say, if you see right here, I say, I'm stable. When we're stable, we persist it in the query store. And we lock it in and say 20 is what we're going to use now. Now the optimizer, even if SQL restarts, says let's go use 20. Because we achieve, at that point, parallel efficiency. And if you notice in this particular diagram, in this particular X event model, again, you don't need X events, it's just showing you the sequence, that we went from 20 down to 16 to 12 to 8, and then we got to 8 and said, whoops, we kind of went a little slower there. Let's go back and we'll stay stabilized at 12. Now what we do in this feedback cycle is two things. We keep trying over time until we get to the point to where I think we've gone far enough to achieve efficiency, or we get to 2. We never go below 2. Those are the 2 ways we decide how far we're going to go. So this is showing you over time what the behavior looks like. And it's just showing X event to see that behavior. So if I keep playing this, what we showed you in the keynote was a way to visually see this. By the way, there's the event that says DOP feedback stabilized, and in the error it says the validation test failed. We just need to say stay right here. So I did go from 32 to 12, and I achieve, actually in this case, a lower duration, and I achieve actually lower CPU. Now let's pause here for a second and see what this looks like. What is this stuff? There is a new DMV called Query Store Plan Feedback. So we are showing you that we've stored feedback in the system. Oh, take a look at that. I didn't even know I had that. So when I ran this demo, I also had memory grant feedback kick in as part of this. This is an example of us persisting things in the query store to make you faster with no code changes. So the DOP feed that's been persisted in this particular case is down to 12. You can see it right here. But if you were to run this query in those cycles as we staircase down, you would see it go from 20 to 16 down to 12, each time storing the feedback as we move in those increments of stabilization. So a nice DMV to kind of track, and in fact, if you run this particular catalog type view DMV, at any time you can see, is SQL Server even trying to do some feedback stuff? You could use X event, but you could also look at this particular query store catalog view. Now, I thought that was pretty interesting, but when I was building this demo and I showed Aaron what I did, it's like, man, Query Store reports, which Aaron just loves, obviously, right, in Management Studio, there's no better way visually to see it than Query Store reports. And so I said, okay, what does this thing look like over time visually? So if you go over here and saw what we did in the keynote demo, we decided to go look at the reports. And the first thing we did, we pause right here, we looked at just average duration first. Now look at that graph on the right. That's over time, starting up top. And as we lower the feedback, we actually end up lowering the duration. Do not count on that. We just try to make sure we keep you the same. And if we go way above it, we stop and revert. So in this particular case, it did get faster, but look at CPU. Let's pause that. That is beautiful. That is parallel efficiency. That little set of dots at the bottom down there is saying, we made it, man. We got down to 12, and we are using a lot less CPU than before. You can see the differences before, almost like a total of 12 seconds overall across all the threads of this query to go down of CPU. So that is the power of DOP feedback put into SQL Server 2022. Let's stop for a second. I think I see some questions showing up on the monitor before I start talking meat and potatoes. Is the query store persisted DOP applied only when the server MAXDOP is set to 0? The answer to that question is no. So first of all, for DOP feedback to work, you must set DB compat 160. You must set the DB option of DOP feedback on, and the query store must be enabled. But here's what we do. Each query is looked at. Is it eligible? Is it running in parallel? Every single query. If we say, oh, it's running in parallel, it's been running for a while, it has a certain duration. What we'll say is, what is the MAXDOP for this query? So it doesn't matter what your MAXDOP setting is, at the database level, the server level, it's whatever the MAXDOP does apply to that query, which could be a database, it could be the hint, it could be the server setting. So we'll take the MAXDOP as your ceiling and try to adjust it. Your MAXDOP could be 8. And maybe if we go down to 2, we'll make it faster. Maybe changing it below 8 doesn't matter. But we take things on a query by query basis. Which IQP features must be turned on manually besides DOP? So in DB compat 160, that's the only one. So if you go to DB compat 160, parameter sensitive plan optimization and CE feedback are automatically considered as options to enable. For DOP feedback, we decided to make that an opt-in specifically as an additional step. It's our intention to make that turn on by default with 160, but today it requires that special turn on. Memory grant feedback, by the way, some of the other ones we talked about, those automatically apply in IQP scenarios. The ones we showed on the screen from 17 and 19, those automatically show up with just using those various DB compat levels. DOP feedback to me is one of the coolest features we've built. I would love to see us in the future continue to use a feedback model like this to make performance faster. Okay, if you have a question, just please put it through the app and we'll address it, or see me at the book signing and we'll certainly talk about it. My mentor, David Campbell, who used to run the SQL Server storage engine organization, told me if we do not innovate the storage engine, we don't have a product. Like, forget about it. And I know you're working in engineering, Bob. See if you can help that legacy. And we've done a lot of work. There are 25 plus engine features in SQL Server 2022. And here are some of the highlights of them. Ledger for SQL Server is a blockchain in SQL Server. There's a specific session at this event just to dive into those details. The workshop dives in details and has an exercise for you to see how that actually works. In the scalability space, did you see me get rid of the latch monsters? I call that hands-free tempdb. And what we've done now in the SQL Server engine with the tempdb metadata optimization on is get rid of latches. Tomorrow in Hidden Gems, I will show you a demo behind the scenes of a deeper dive from what we flew through in the session, because to me, it's a hidden gem. It's like a thing we just built in there and people don't realize we've actually done that. And then look at this stuff in availability. Let's go talk about contained availability groups. Aaron talked about the fact that SQL agent jobs have finally made it. So real briefly here, this is what the architecture looks like, just to be clear how it works. If you build an availability group now in SQL 2022 and declare it with a keyword that says contained, just what you add, here's what we do. We take the current master of your instance and take the sysadmin logins and copy those into a new master. That new master is effectively a user database. And you're like, what? So here's what we do. We build 2 new user databases in your AG, no matter how many user DBs are in there. We take the sysadmin logins and put it into that new master. And you're like, I don't get this still. What's going on? If you connect now into your AG with the listener or the database context, you are redirected to this master at MSDB. So let's say that you connect with the listener into this model, and you create an agent job like Aaron did. You know where it goes? It goes into that MSDB, and SQL agent now knows to run jobs in that MSDB or this MSDB. Even better, since these new databases are part of an availability group, what happens to changes in databases and availability group? They are shipped over to the secondary. So now by default, your agent jobs, your logins, get shipped over to those replica copies on the secondary. SQL agent knows on that secondary, only run agent jobs for the MSDB in the instance. Don't run them in anything that's part of a replica contained AG. Well, you're saying, Bob, that's still not the final answer. So what Aaron showed you is a failover from this primary to the secondary. This becomes the primary. Agent now can run jobs in either MSDB. So what I'm suggesting to you, if you go to this model, is now you can get rid of agent jobs that say, am I running on a primary? Because if you are running in a primary and you have this model set up, we will run your agent jobs running in that AG. But here's the key. You got to be connected to the listener or database context to create instance objects to make sure they're replicated in this system. Super excited to see this finally happen because a lot of people have been struggling with this design. But that's the key. Notice the difference here between connecting into the instance, and that's what Erin was showing you in the demo. She said, oh, here's the instance, and you see these databases show up. But when I connected it into the actual listener, I only saw the context of what's in my actual AG scenario. Pretty excited to see that feature land. Okay, let's stop for a second and see. There's a couple other questions here. You mentioned that DOP flag never goes below 2. Is there a reason not to go to 1 in case the cost of going parallel itself could be beneficial? Yeah, the only reason we decided is that we didn't want to turn off parallelism, to be honest with you. We don't want to go down to the level of saying, oh, okay, we're just not going to use parallelism. The intention of the feature is parallel efficiency, not to not use parallelism. Will MAXDOP feature be available in the previous release of SQL and a CU update? The answer to that, not likely. Most likely that'll stay in SQL Server 2022 and it'll be available in Azure SQL. So contained AG, great feature as part of the meat and potatoes of SQL Server. So the last thing I want to show you is data virtualization. I flew through the kingdom of Dell will respond to A. That was quite funny, wasn't it? I didn't even know they were going to do that. So we did work with Dell on this one, though. So we talked to Dell as an organization and said, look, don't you support S3 as an object provider? They're like, we sure do. We talked to Pure Storage. We talked to some of the icons you see on the screen right here, HPE, ManIO, Ceph, Cloudy, and Hitachi. We talked to Amazon. It turns out S3 storage is an open protocol. The S3 protocol is open. Simple storage service invented by Amazon. They opened up the REST API protocols on how to interact with something called S3. So all these vendors said, we're going to go do that. So we were building Project Dallas, and a really brilliant gentleman named James Roland Jones, who you may know and love, doesn't work at Microsoft anymore, said, let's go do that. And that's what we've done with Polybase. You can still use the ODBC services in Polybase for things like Oracle and Teradata and HANA and MongoDB and et cetera, built-in drivers. Or you can use the new REST API interface built into the engine to access Azure Data Lake, Azure Blob Storage, Dell, HPE, and here's the killer. You can do now natively Parquet and Delta. We recognize what those file formats look like. So this story of data virtualization to me is extremely powerful. And in fact, what I'd like to just briefly show you and flip over, thank you very much, is an Azure Data Studio notebook. And won't Aaron be proud of me? This is in the workshop. You can just go look at it yourself. I want to scroll down here. This is some of the basics of getting going. The external data source is key. This is the location of the S3 bucket, or the S3 system that I'm actually accessing. In my workshop, you can even do it for free with a local MinIO server. So I'm going to create an external file format for Parquet here because I'm going to do something very interesting. I'm going to use what we call CTOS. I'm going to go create an external table, which is metadata in SQL Server, and export a SQL table into Parquet into a different storage location. That is pretty cool, because then I can turn around and query the external table itself as a table. And I don't even know it's Parquet. In fact, I can join with existing tables in SQL Server. Now, also the thing I love about this entire system, if you scroll down a little further here, is immediately I can just also use Open Row Set. I don't even need to create an external table. I can just do ad hoc type querying across my Parquet data and look back at it as an actual table, and I could create a view on top of that I want to. So external table is schema, metadata in your system, or Open Row Set is just an ad hoc way of going after it. That's a great way just to test it. Can I get access to it if I set everything up? But there's more. I love some of the things we've done here. Look at this one. You can go here now and create an external table. Let me scroll down a little bit here. I can create statistics against the columns in the Parquet files, which will help with things like join decisions. Or this is really cool. I can go down here and do this one. I love this. I can run a stored procedure against my Parquet, and it'll come back with the metadata in the Parquet. So I can go down here and say, you know what? I don't even really know what's in these Parquet files. Let me run the stored procedure, and look at this. I get back a table of the types and the columns of the Parquet files. I love that. Because somebody can say, hey, here's a bunch of Parquet files. Can you go query on this? Well, I don't know what's in this stuff. I don't know how to read Parquet. I can write a program for it. Or you can use a stored procedure to go see the metadata of what that actually looks like. That's actually pretty cool. And then finally, there's a built-in set of file functions here. So let's say that you set up one of these S3 storage providers or Azure Blob Storage with a bunch of Parquet files, and you're like, I don't even know what the files look like. So I have this built-in file path function and file name to go down and say, what is the name of the actual Parquet? So the ability to go after data where it lives, to export data out to data lakes, to go discover what the data is, all to the T-SQL language, all in the language you know and love. I'm excited to see that functionality land with customers more and more. Okay, so let's just get one more question here before we wrap up. A couple of questions. With DOP enabled, will a query that has been analyzed in MAXDOP set ever be reanalyzed? What a great question. Yes, we will reanalyze this decision on recompile. So if you've put it in this feedback in the system and we need to recompile the query, we will go back to the eligibility process to say, should we still do this? And is that DOP still applicable? So we do reanalyze that scenario. But remember, we never go above MAXDOP. How does contained AGs detect agent jobs that are local and agent jobs that are synced in MSDB to the secondaries? They are both created in MSDB. We also want jobs to run always on all nodes. Great question. And it was a really hard diagram. It's hard to put your head around it. So agent is designed to say, hey, I'm going to run agent jobs that are in the instance MSDB, and I know how to go look for MSDB databases in contained AG, so it could be multiple. And if it's on a primary, I will also run the jobs there. So if you want to make sure jobs are always run on all nodes, put them in the instance MSDB. But if you want agent jobs to only run on primaries in a contained AG, it will do just that. And when you fail over, it would run the job again as the new primary. So if you've got jobs that are looking for, if I'm in primary, you don't need to do that anymore because our new technology supports that. But if you still need to run jobs on a secondary and make sure they always run, you can do that by putting them in the instance MSDB. And how do you know you're doing that? Just connect to the instance. Don't connect to the listener. because the listener redirects you to this new contextual MSDB system. Okay, that's data virtualization in SQL Server. In the Hidden Gems section, I've got another proposal for you of something that you might find interesting to try out that technology. The wheel of power is quite amazing. I think people thought SQL Server was dead. And I have to admit to you, during calendar year 2021, I started working on SQL Server 2022 back in 20. All of calendar year 2021, I sat at my home in Dallas, Texas, in Northwest Hills, Texas, saying, I want to tell the world about SQL Server 2022, and I couldn't do it. Right, people would ask me, is there a new version of SQL Server? I'm like, you know, Microsoft we work always on, blah. Yeah, I just had to do the rote company answer. It was such a privilege to finally get to announce this preview in 2021, and then even bits last year to show you this, and finally here today to show you all the things we achieved in the release, and to just let you know what's going on. I'm even thinking about the next one. We started thinking about the next one before we even shipped this one. So SQL Server is alive and well. I'm going to leave you with this. I'm going to leave you with resources. We're just right out of time. I actually finished in 50 minutes. I think I deserve some applause just for that. So I'm just kidding. For 50 minutes. Bob Ward finished in 50 minutes. Hey, I'm going to leave this up for you. These are resources you should check out. We have put our heart and soul into this release. There's videos, there's workshops. If you'll come here in about 10 minutes, I'll show up at the booth and get writer's cramp signing a bunch of books. It's my honor and pleasure to do that. It's my honor and pleasure to come SQL Bits. I hope you enjoy the rest of the conference. Thank you.